So this talk it's a little bit different. I've not tried this particular framing before. It has a little bit of a personal connection. So I hope that you you go with me on this. So let's just jump into it. Let's start with an introduction. So who am I? What do I do? And why am I here? So I'm Matt Wilson, and I'm an engineer. And I'm humbled that an organization like Amazon decided to put distinguished in my title. I'm asked, what does a distinguished engineer at Amazon do a lot? And candidly, I'm kind of still figuring that out. There's just so much change happening right now that sometimes it can feel a little overwhelming. I've been at Amazon for a little over 16 years. I was hired as a principal systems engineer on the kernel and operating system team. And so I call myself a systems engineer. I think in systems that span many technologies and disciplines. Our technology stack spans all these different dimensions that come together ultimately to serve our needs. So to me, systems engineering is all about balancing trade-offs and constraints to deliver practical, cost-effective solutions, no matter if we're talking about hardware or software or networking or power or processes. Systems are more than the sum of all the components. So at Amazon, most technologists that are hired at the principal level are software development engineers. And among my distinguished engineer peers, I'm the only one who came up through the systems development engineer job family. Though I consider many of them to be fellow systems thinkers. So one of the things I feel called to do at Amazon is to advocate for systems engineering as a discipline. When I reflect further on what it is I really do, I consider myself a socio-technical systems engineer because I feel that it's really important to highlight the human elements of systems engineering, because it's really easy for technologists to focus mostly on the technology, and that can ignore what I think is the most critical part of engineering, which is making sure that the people who rely on the systems that we build, that they are well served by what we build, that they can rely on it, right? And there are human factors that determine how well they will be met, and also how well we will, from a sustainability perspective, the engineers who are building these systems, how that will work over time. So that means that in my engineering, I include how we organize and plan and operate at a people level, because no matter how much AI we bring to this work, I think that it will continue to be a human-intensive effort for at least as long as I am a practicing systems engineer. So this kind of socio-technical systems focus leads me to work on some amazingly complex and challenging problems. I started my professional career at Red Hat in the early days. So I feel an affinity for all things at the Linux Foundation and open source. I've been fascinated with how open source software works, how communities form and grow and fade away from the days when we called it free software. So today I'm part of Amazon's software builder experience team. And so we are responsible for all the software engineering systems at Amazon, including AWS. So part of what I do is I try to make these systems work well with open source, and I try to provide information, knowledge, and tools so that our software developers work well with open source. Right now, I'm also spending a lot of time addressing the concerns of AI-discovered vulnerabilities in open source software. That takes up a lot of my day. And then responding to supply chain attacks and compromises on GitHub is taking up a lot of my nights. So software engineering and life cycles, the life cycles that software developers use to do their work, it's also an area of real intense focus for me. So that's also a socio-technical systems effort. So understanding how teams go about planning their work, share knowledge with one another, learn how to not only build software, but operate it in production, and how to build resilience in everything they do is core to the work that I do within Amazon Software Builder Experience today. And another area where I feel drawn personally is studying concepts like security and reliability, trust and trustworthiness, because those are very deeply human processes that need to be considered when we build technologies that can have real consequences on people's lives. I think it's highly relevant to confidential computing. And I think doing this job well demands a holistic systems approach. So I promise I'm going to talk about the Nitro system, but first, I think it would be helpful if we shared a common mental model for systems engineering and shared vocabulary about building trustworthy, secure systems. So I think that let's return to principles, right? So I think to get on the same page, let's start with the goal. And then we can work backwards to learn about some principles that can help achieve that goal. So here's the objective from my point of view. So our objective is to design and deliver an engineered system that reliably delivers on its intended function while ensuring that only the intended behaviors and outcomes occur with both within the system and the system as a whole. Then, as an engineer, we need to generate and provide evidence that can support as the grounds for a justified confidence that claims about that system have been or will be achieved. And that is how we establish trustworthiness. Yesterday, there were some discussion during the keynote panel session about trust versus verified or justified trust. So that, to me, is what I call establishing trustworthiness. And I'm not inventing this vocabulary and this framework myself. This all comes from a document that NIST published in 2022 to help advance this idea of building trustworthy and secure systems as a systems engineering discipline. And I really wish that this document had existed when we started designing the Nitro system in 2013. Because the principles and techniques in the guide aren't new. Like we applied a lot of, I think, sound principles at the time, like least privilege and this and that. But the holistic systems framing, I think, is new. So this guide can tell us how to apply a holistic multidisciplinary systems thinking and how important that is for achieving security assurances. The guide includes 20 principles that can be applied in the system engineering discipline that can help achieve an appropriate level of security. And that's a defined term in the framework, like understanding what the security concerns are and how those can be appropriately met by a system, right? They provide a basis for reasoning about a system, and they shouldn't be applied as rules to be complied with or prioritized or sequenced or ordered or prescriptive. This is a tool that you can use as an engineer to make sound judgments about conformance and about managing risk. They're tools for our brain, right? They can help establish that common vocabulary and mental models across the community practice, which is important when I'm trying to convince someone who is a fellow practitioner in systems engineering that the claims I'm making about a system are justified. It's helpful to have this shared vocabulary and mental model for the work. So today I'm going to touch on just a few of these principles and how they can be applied to the Nitro system. So first, let me talk about a brief overview of what the Nitro system is. So Nitro system is purpose-built to be trustworthy, foundational component for EC2 provides virtualization so that we can take the resources that are running in the cloud and partition them into separated customer instances. There's a reason why we included system next to Nitro from day one. It's because this is a combination of hardware and programmable elements that work together to protect customer data while not compromising on the performance, reliability, or other operational characteristics. So first we have Nitro cards. Those serve as the hardware root of trust for the system. Those cards are built using system-on-a-chip ASICs from Annapurna Labs, which is the custom silicon division of AWS. Inline, they provide secure I/O virtualization for networking and storage, and inline data encryption, and removes those responsibilities from a host-based hypervisor. Therefore, the next component, the Nitro hypervisor, is radically simplified. It only needs to program the hardware so that isolation can be enforced by the hardware. The Nitro hypervisor is based off of Linux, but only the required subsystems are compiled. Our system design also includes a security chip on the system mainboard, which enables the Nitro card that serves as the hardware root of trust to measure and control all firmware components and mediates control of all system management interfaces. And so the Nitro system is the foundation for the security and the data protection of EC2. And there's some very specific elements of the Nitro system design that are important. First, there's a secure boot process that's based off of the hardware root of trust in the Nitro card. And it ensures that the integrity and authenticity of every programming component of the system. So you can think of programming components as firmware or software, but I just think of like the parts of the system that program the hardware. So programming components are minimized and implements only the required functionality. Hardware-based isolation is enforced by hardware, but programmed by those trusted programming elements. And we also have hardware-based inline encryption of all storage and networking, and on many of our systems, we have inline memory encryption as well. No AWS operator has access to the Nitro system. That's in the basis of the design, right? All operations on Nitro infrastructure are invoked via secure, authenticated, authorized, logged, and audited APIs. No APIs provide access to compute, instance memory, or storage contents. So I want to try to convince you that the Nitro system is trustworthy. So how can I do that using the framework? I'm going to make specific claims, and then I'm going to try to provide some evidence that I think will help justify that claim. So first, I claim that the Nitro system implements sound early boot firmware needed for trustworthy, measured, and secure boot functionality. So how do we build the assurance for this as engineers, and also for someone who's a concerned user of the system? Well, we have to make sure that from the very first instructions that come up when the system on a chip boots, which is in ROM, that all of that is sound, that we have assurances that that software has no memory, safety errors, or correctness from the very first instructions. And so we apply, I think, an appropriate level of rigor in building these components that are the critical components of the system, that we have can come to a justified conclusion that it is sound. So we published a paper in 2018 that made some very precise claims about how we proved properties of the boot code for the secure boot of the system. And it was 783 lines of code that were proven, which was no small amount of work at the time. It's also, we had to address a number of challenges proving, using the tools that we have at the time, proving code in kind of early boot modes of execution for the processor. So I have another claim, the second claim, that the Nitro system implements a single encrypted operational API control channel where all operations are authorized and audited. So this one, there are a number of subclaims that support this broader claim. And to get to sufficient level of detail with someone to evaluate this, we worked with the NCC group to evaluate the security design and the claims that we made. And it came to a conclusion that the evidence that we supplied supported those claims. You can get to the report on the QR code. And this is, I think, we've been continuing to enhance and grow the assurances we've been able to make over time. So in the beginning, we started with a very small amount of kind of formal modeling around early boot firmware. But we really want to be able to extend that to more parts of the system. So our latest claim is that the component that's responsible for programming the hardware isolation functionality of the Nitro system is free from memory safety errors, runtime errors, and is functionally correct. And so our latest release of the latest generation of Graviton processors utilizes a new component that enhances the overall trust posture of the Nitro system. It's called the Nitro Isolation Engine. This is the first formally verified production cloud hypervisor. It's 330,000 lines of machine-checked mathematical proof. And it's comparable in overall scale of effort to the SEL4 project, if you're familiar with formally verified operating systems. So this is a mathematical proof that the VM isolation that is implemented in this element of the system of the stack is correctly enforced, not just that we've tested it sufficiently. In order to actually have an assurance that the confidentiality integrity that we want to have through the hardware enforcement of the virtualization, you have to build that from a number of steps along the way. So you have to demonstrate that the code is free from memory safety hazards. So no null pointer dereferences, no use after free errors. You have to demonstrate that it has no runtime errors, such as unreachable reachable panics and things like that. You have to demonstrate that it has functional correctness. It doesn't have logical errors. And from there, you can demonstrate that the confidentiality and integrity that is enforced in hardware is correctly implemented. We have a white paper that we recently published about the Nitro Isolation Engine. There's also a presentation from the team that they gave at re:Invent last year. And so let's look ahead. This is kind of gets to the part of like, okay, we do all this work to establish Nitro system as the foundation of trust and trustworthiness, not just trust me, but please verify my work and come to your own justified conclusions. What can we do with that? So I think this is no big surprise. There are a lot of concerns related to AI, and confidential computing, I think, shows a good promise for addressing them. In particular, model weights providers want to have assurances that those weights are protected in production. And so today we have implementations of the Mantle inferencing engine as part of Bedrock, which is AWS's inference as a service. It uses the Nitro system to provide an attestation about what's running inside of the inference environment, and that it too is built with no operator access, and model providers can be assured that model weights are adequately protected. And how does this, like, for anyone who is like looking to implement confidential computing and using Nitro, like, how would you start? Hopefully, I'm curious. Is anyone in the audience are using confidential computing functionality like Nitro Enclaves or Nitro attested instances? Okay, that's good. I think one of the things that I always ask is, like, do you have an understanding of what it is you're protecting? Who are you protecting it from? And then we can help you map that onto how AWS can help. So first, for all Nitro system instances, like the assurance that you're protected, your data, like the cloud operator has no ability to access customer content, that applies no matter what. Like, it's not an optional feature, it's always on. And you don't have to do anything to get those assurances. If you want to do other things like provide a remote attestation of either a Nitro Enclave, which is a feature of the Nitro system, or Nitro instances, you can do that as well. You can use the trust that you, I think, can have in the Nitro system to demonstrate to someone else that this is the code that's running inside of an enclave or inside of an instance. So you can get more information at this landing page. And I wanted to close with like one more thought. This is a quote from, I'll call Corey my friend. Yeah, Corey is my friend. And he trusts Amazon. And so this is he wrote an article in the Register last week where he, the Register editor said, blink if you're in trouble or something like that. So I think that trust, as Mark was saying yesterday, is a complicated equation. And I think that trust is earned. And no matter what we get wrong in Corey's eyes, I think that he recognizes, at least from his perspective, that we take security and data privacy deadly seriously. And for engineering, that's something that we really internalize as core to the mission, and something that becomes really, we have to do our work in ways that withstands any level of scrutiny. It's difficult to provide complete transparency because you have to balance a number of concerns about confidentiality, intellectual property, and also giving ourselves the flexibility to make changes that continue to improve the system without having to go back and re-evidence everything. So I think that there's a theme in a lot of confidential computing discourse that kind of boils down to this. The cloud provider can't be trusted. You should just assume the cloud provider is hostile. And the software that cloud providers develop, like a hypervisor, must be assumed malicious. I think it's a healthy overall approach to assume all components of a system could be compromised. That's a good defense in depth. But that's different than just an assumption that a cloud provider, merely due to being a cloud provider, can't be trusted. I think there's a theme that software-based trusted execution environments, whatever software-based means, are weaker than hardware-based trusted execution environments. In fact, all these systems are systems of both hardware and software elements. All of the attestation programming for all of the trusted execution environments that I'm aware of are implemented in software. And so we need to apply rigorous methods to ensure that those software implementations are sound. And that should be part of what we expect from anyone who is trying to convince you that their technology is trustworthy. So I have generally a personal belief that people should have a right to evaluate what's right for them. And so I encourage everyone to accept that some people are going to trust a cloud provider, and some people are going to say, I have to trust a third party. And with that, I think I ran right at time, and hopefully, do we have any time for questions? No? Okay. Thank you.